Hey everyone, we're going to do this activity titled "The Math is Getting Grander." Um, should be a pretty quick, short, easy one. Me and Mr. Wong both felt like maybe we gave you a couple of tough homework assignments last week, so we decided to give you a shorter, easier one this week. So let's get to it. The first screen, I think you can do that one without my help. Share something happy or funny that happened to you. Maybe make a sketch if you want. The next one, some graphing practice. I don't think we've done as much graphing this year as we would normally do in 7th grade math. And so we just wanted to refresh your memory. And I think if you connect all of these coordinate points together correctly, it's going to make like some kind of picture or design or pattern for you. So let's graph a few of them. I'm not going to do the whole thing because that would ruin what it looks like for you when you do it yourself. So um, the way it works is you graph and connect the points with using lines up until the point it says stop. Then you start graphing the new set of points and you connect them, but you don't connect the ones to previously before the word stop. So for example, I'm going to graph the point -3, 5. So that means I start at the origin 0, 0, and I go to the left 3 spaces because of that -3. And then I go up 5 spaces because of that +5. And I'm going to graph a point right there. And then I'm going to graph the next point, which is -3, 4. So that should be right underneath the one I just graphed. And then I'm going to do -3, 3, which should be right underneath that one. And then -3, 2, which will be right underneath that one. So we got 4 points all in a straight line. And so I can connect those using the line tool. So that'll be nice and straight. And then I stop. So I'm going to start drawing a new line now, and I won't connect those to this one. So the next set of points starts with 3, 5. So that's +3 from the origin on the x-axis first, and then up 5. So here. And it looks like it's going to be the same pattern as last time, right? It's going to go 3, 4, 3, 3, 3, 2, and then stop. So I'm going to just make a point. Each of these coordinate pairs, one space lower on the y-axis. So there's my 3, 3, and there's my 3, 2, and I'll connect them. All right, and then the last set of points you have to draw is obviously much larger, but I think you get the idea at this point. Just graph the points, connect them all together, and it should make some kind of picture here for you. So start with -4, -1, -4, -1 will be right there. And I'll let you continue from there. You can finish it. Let's move on to the next one. Let's see. It says, oh no, Mr. Wong had a concussion. He forgot how to solve equations and what the steps are. Please help him. Explain the steps to solve the equation below and give him the final answer so he can check his work. Okay, so we're supposed to solve this, but we're supposed to explain how we would do it along the way. So I look at this equation and I notice that the variable x is being multiplied by 5 and 3 is being subtracted. And so I know that I want to undo both of those things using opposite operations, or inverse operations is even the better word to use. And we have to do it in reverse order from GEMDAS. Normally GEMDAS says, let's multiply, then subtract. So we're going to go backwards. We're going to add and then divide. So I would say start by adding 3 to both sides of the equation. And so after we do that, the new equation is 5x equals 40, right? The -3 creates a 0 with the 3 we just added, and the 37 becomes 40 because we added 3 to it. Now divide both sides by 5. And when we do that, the 5x divided by 5, the new equation, so 5x divided by 5 will become just an x. And then on the other side, 40 divided by 5 is 8. So that equation is our solution, x equals 8. All right, let's do the last one. We have 9 equations here. And the instructions say that each solution matches 2 equations. So let's get those solution cards like kind of grouped up. I see an x equals -3. I see an x equals +4. And I see an x equals 1/3. Okay, so we could solve the equations and see which of these 3 solutions they come up to, or we could do it the other way. We could act like we're verifying the solutions, which would mean we substitute the solution, the value here on this card, for x in each of these equations and see which ones work. I see a pretty easy one right off the bat. I see here it says 10 times x equals -30, the one that I'm kind of circling around. Well, I know that 10 times -3 equals -30. And so I want to connect this -3 solution to this one. Or maybe we'll come back to that one. I see another pretty easy one over here though, right here. 2 times something plus 2 equals 10. Well, that means the 2 times something part has to be 8, right? Because then 8 plus 2 is 10. And so 2 times that something equals 8. I think that x has to be 4. So I'm going to connect the 4 here. Let's put that over there. All right, and then let's see here. Here I see 18 times something plus -3 equals 6. Well, I know that 6, sorry, I said equals 6 because I was thinking about the next thing I was going to say. The next thing I was going to say was going to have a 6 involved. But no, it says 18x plus -3 equals 3. And I know that if 18x itself was 6, then we would have 6 plus -3 equals 3, which is true. So I need 18x to equal 6. Well, 6 is a third of 18. So if I multiply 18 by 1/3, I would get 6. And look, I have a solution right here where x is 1/3. So now the equation says 18 times 1/3, which equals 6, plus -3 equals 3. That's a true equation. All right, so now we've got at least one equation matched with each solution. Now we just gotta basically do it again. All right, here I see x times something minus 1 equals -25. Well, if 8x equaled -24, and then we subtracted 1 from that, we would get -25. So I got to make 8x equal -24. That would be 8 times -3, right? The x would need to be -3. That's this set of cards right over here where x equals -3. So I'm going to put that one there. All right, let's look at this one. 12 times something minus 5 equals -1. Well, I know that if it said 4 minus 5, that would equal -1. So that means the 12x needs to equal 4. Well, 4 is a third of 12. So if I just do 12 times a third, I'll have a true equation. So this one needs to match up where 1/3 is the solution. That only leaves us with one more. By process of elimination, we know where it's going, but let's look at it anyway. So I'm pretty sure the solution is going to be 4, right? I already know that it's probably got to go here. So let's just check it. -3 times 4 would be -12. If you add +7 to that, you do get -5. So indeed, this one's going to go there. All right, that's it. Hopefully that homework was a little bit quicker and easier for you than some of those tougher ones we gave you last week. And we'll see you in class next time.